Let's now write a program using arrays, pointers, and function calls. So here we have a list of 5 elements, 1, 2, 3, 4, and 5. The contents are 2, minus 1, 0, 3, and 7. And our target is to increment the array contents by 2. So 1, 2, 3, 4, and 5. The final array should be 4, 1, 2, 5, and 9. Let's see how to write this using pointers and function calls. Main function, int list of 5 equals, declare the 5 values. Next, I'm going to write a function, void add to int star ptr, comma, int n. I'm going to explain what they do. And my call would be add to of ampersand list of 0. So I'm sending the base address of the array, which is in this case, let's say 4000, and I'm sending the size of the array, which is 5. Now let's go to the function and see what happens. So void add to int star ptr, comma, int n. I'm going to declare a variable I, and I can write for I equals to 0, I less than or equals to n minus 1, I plus plus. Remember, n is 5. I can say star ptr equals star ptr plus 2, and then increment the pointer. That's it. So the given array was 3, 4, 5, 2, minus 1, 0, 3, and 7. And let's say the address was 4000, 4004, 4008, 4012, and 4016. So this initially contains 4000. So for the first iteration of the loop, we say star ptr equals star ptr plus 2. So this location is now 4. And when I do ptr plus plus, my ptr goes and sits at 4004, which means it's going to contain 4004. For the second iteration, again, I can do star ptr equals star ptr plus 2. So this location would now store 1. And when I do ptr plus plus, my ptr is now going to point at 4008. Similarly, for the next two iterations, we first modify this value by adding 2 and then move the pointer. Same thing again, we modify this value by adding 2 and we move the pointer. Finally, we are going to modify this value here and move the pointer to the next location. For the last one, we do not know where that location is going to point to, but we don't care because we are able to access all the elements in the array and modify them. There is another way to write this program, which is for I equals to 0, I less than or equals to n minus 1, I plus plus. I can simply say pointer of I equals pointer of I plus 2. So basically, when you have pointer of 0, it means that it's basically star ptr of 0 equals star ptr plus 4 times 0 plus 2. So this translates to this one here. And if you have ptr of 1, it indicates star ptr of 1 equals star ptr plus 4 times 1 plus 2. So you can use both of these, and both of these are equivalent. As I said, sometimes I'm going to use this setup and sometimes I'm going to use this setup. This setup involves only one line of code. This involves two lines of code. So let's complete the main program. I can declare another variable I, and I can say for I equals 0, I less than or equals to 4, I plus plus, printf, percentile d, comma, list of I, end of main. This program solves two issues. The first issue is the number of calls. Again, we are only calling the function one time. So we can get that speed and we can save some time required for making the function call several times. So just one function call. The second problem that we have solved is, instead of making an entirely new array, all we did was we sent the base address of the array and collected in a pointer variable. Remember, it's an integer pointer, so it's going to occupy 4 bytes in memory, and int_n is another 4 bytes. So it doesn't matter what the original size of the array is. All we need to do is send the base address of the array and collect it in a pointer. Now imagine if this array contains 500 MB of data. If you remember in the earlier problem, we made another array, so we had another 500 MB here. So that's 1 gigabyte. But in this case, we have 500 MB of data plus an additional 8 bytes of data. That is very less compared to what we had in the previous case. You're getting almost 50% memory savings. So that is why pointers are a very powerful construct in C programming.